We all know that volcanoes are hot, but have you ever wondered why? Why do some places on Earth have so much volcanic activity? Why is it so common in Iceland or Japan? And how can we use this energy to power our homes? In today's episode, we are going to learn about eruption zones and the science behind harnessing geothermal energy. This is Crash Course Geography. Hey there, welcome to Crash Course Geography. Today, we are going to talk about volcanoes and geothermal energy. To understand where volcanoes come from, let's look at the layers of the Earth. There are three main layers: the crust, the mantle, and the core. Now, these layers are not uniform. We can break the crust into two types: the oceanic crust and the continental crust. Oceanic crust is the ocean floor, and it's made of dense rock. The continental crust is the land that we live on, and it's less dense than oceanic crust. The mantle is hot, dense rock, and it's mostly solid, but under intense heat and pressure. And then finally, the core has a solid inner part and a liquid outer part. It's also very hot. Like, the inner part of the core is 5,000 degrees Celsius, which is 9,000 degrees Fahrenheit. That's like 10 times hotter than the surface of the sun. So why does this matter for volcanoes? Well, if you've watched our episode on plate tectonics, you know that the lithosphere, the crust, plus the rigid part of the mantle, is broken up into tectonic plates that move around on top of the rest of the mantle, which is kind of like a thick liquid. Sometimes these plates collide with each other, and because the plates on top of the more liquidy mantle can move around more easily, sometimes an oceanic plate carrying continental crust will slide under an adjacent plate. When this happens, we call it subduction, and the place where this happens is called a subduction zone. Subduction zones are usually where volcanoes form because when an oceanic plate carrying continental crust dives into the mantle, the intense heat and pressure melts some of the rock, which creates magma. The magma is less dense than the surrounding rock, so it floats up toward the surface. And when it reaches the surface, we get an eruption and a volcano. So one thing that makes a good geothermal site is being near a subduction zone. Another great place for volcanoes to form is at plate boundaries, where two continental crust plates collide. Let's take the Eurasian plate and the African plate. They're colliding with each other, but neither one is subducting under the other. So instead, the crust kind of bunches up and is pushed up into mountain ranges like the Alps. Mount Vesuvius, which erupted and destroyed Pompeii, Italy, and Mount Fuji in Japan are both formed this way. So being at a convergent plate boundary can be another way that a place can end up with lots of volcanoes. But wait, there's more. Volcanoes can also form at places called hotspots. Hotspots don't have anything to do with tectonic plates. Instead, hotspots happen when magma plumes rise up from deep within the mantle, like maybe 300 kilometers or 200 miles below the surface. Hotspots are stationary, but over time, the plates move over them. As they do, new volcanoes form. Over millions of years, these volcanoes build up and eventually become mountain chains. The Hawaiian island chain is an example of volcanoes forming at a hotspot. If you were to look at a map of the Hawaiian Islands, and you traced a line through the middle of each island, you would see that they trace a line almost due north. The islands are older and smaller to the south and younger and larger to the north. That's because the Pacific plate has been moving roughly southwest over the hotspot, and the oldest islands formed when the plate was over the hotspot a long time ago. Newer volcanic activity has built up more land since the plate has continued to move northwest. The current island of Hawaii is the youngest and the largest. Okay, so those are the three ways that we get volcanoes: subduction zones, convergent plate boundaries, and hotspots. But not every volcano becomes a mountain. Some volcanoes are actually under the sea. And you probably guessed it, these are called seamounts. Seamounts are underwater mountains, and some of them are actually volcanic. Many seamounts are the result of hotspot activity on the seafloor. Since water is so much denser than rock, even though these seamounts are huge, they don't reach the surface of the water. The highest seamount in the world, however, does reach the surface. It's a massive mountain that is over 3,500 meters, or 11,000 feet tall. It is located in the Indian Ocean between Madagascar and the mainland of Africa, and although it's over 3,000 meters tall, it still doesn't breach the surface of the water. The water level is only about 600 meters or 2,000 feet below the top of the mountain. If you want to build a geothermal plant, having a volcano nearby is really helpful. That's because geothermal energy harnesses heat from the Earth's interior. Places with lots of volcanoes, like Iceland, the Philippines, and New Zealand, are great for geothermal because all of that volcanic activity means there is extra heat in the Earth's crust in those places. Geothermal energy is renewable because the Earth constantly replenishes its supply of heat. Unlike fossil fuels, geothermal plants produce very little pollution, making them a very green energy source. The downside is that while it's renewable, it's not technically inexhaustible. We can't simply make more heat appear. Instead, we are tapping into heat that is already stored. In addition, the reservoirs of hot water or steam are localized, and not everywhere has the same amount of geothermal potential. And since drilling into the crust to access this heat is super expensive, geothermal plants are rare. But there are a few different kinds of geothermal systems that we can harness. The type we usually think of is called dry steam. Dry steam is exactly what it sounds like. Steam rises from the earth and powers turbines connected to generators to create electricity. But not all geothermal sites have enough steam to make electricity this way. In places where there isn't enough steam, engineers can circulate water through the hot rocks. The water turns into steam and then powers the turbines. We call this type of geothermal power plant a flash plant because the high-pressure liquid water flashes into steam when it reaches the surface. In places where the temperature isn't quite high enough to turn water into steam, engineers circulate a special fluid through pipes under the ground. The fluid absorbs the heat and then goes to a power plant above ground, where it releases the heat and turns back into water. This type of geothermal system is called a binary plant because two fluids are used, the working fluid that picks up the heat underground and the water that receives the heat above ground. Binary plants aren't used for electricity generation, but they can heat buildings or even aquaculture operations like fish farms. So now, you know how we get volcanoes and how we can use them for energy. Next time you're near a volcano, you can feel pretty connected to the center of the Earth. Many places where volcanoes occur are along what scientists call the Ring of Fire. The Ring of Fire is a horseshoe-shaped belt around the Pacific Ocean where volcanoes and earthquakes are common. Much of this belt lies along plate boundaries, which makes it a great place for volcanic activity. In fact, 75% of the world's active volcanoes are in the Ring of Fire, and 90% of the world's earthquakes happen here, too. Some of the most well-known volcanoes are in the Ring of Fire, like Mount St. Noggins, Mount Pinatubo, and Mount Krakatoa. But the Ring of Fire is also home to many active volcanoes like Mount Vesuvius, Mount Fuji, and Mount Rainier. These volcanoes are considered active if they erupt often and have erupted in recorded history. Scientists closely monitor these volcanoes for signs that they may erupt again. And although volcanoes can be dangerous, humans have lived near them for thousands of years. People have settled in places near volcanoes because the heat from the earth makes great farmland and geothermal energy. But predicting when a volcano will erupt is really hard. That's why many countries have agencies dedicated to monitoring volcanoes and communicating the risk of eruptions to people who live nearby. One of the most famous eruptions in recent history happened in 1980, when Mount St. Helens in Washington state erupted. The eruption was so big that it changed the shape of the mountain and left a crater 2,400 feet deep and 1 mile wide. Mount St. Helens is the site of the most violent eruption in U.S. history. Volcanoes are fascinating geological wonders. They are also a source of energy that humans have harnessed for thousands of years. Next time you feel a lava lamp bubbling away or your toaster making your breakfast, remember that you're harnessing heat from the center of the earth. Thanks for watching this episode of Crash Course Geography, which was filmed at a studio and made in partnership with the Digital Studio and Nature. You want to help keep Crash Course free for everyone forever? You can join our community on a crowdfunding platform.